Thank you all. It's a Friday night. You could be doing anything, and you're spending some time with us, and I really appreciate it. And we're going to do what we can to make it worth your while. So, just a quick introduction. This is me. I'm Erik Gross. I am a senior level software developer. I've been working in tech for decades, as you can tell by my gray hair. I'm a Navy veteran. I was a nuclear reactor operator and electronics technician in the Navy a long time ago. And I'm also the co-founder of the Tech Academy. And I'll be your host tonight. I'm really glad you're here, and hopefully I can give you some really valuable information. We have an assistant in the chat, Assistant Cheska. She's awesome. Her role is to monitor the chat, answer questions, and give you the ban hammer if you're not nice, but that rarely happens. I'm not worried about it. We've already used chat a fair bit. I'm sure you're all familiar with how to use chat, but do me a favor. If you haven't dropped into chat and let us know where you're joining us from, drop that in. I'm in Louisiana right now, near New Orleans. Let me know in chat where you're coming from. If you haven't already, a lot of you have. We got people from Pittsburgh and Denver, and Milwaukee and Indianapolis. Atlanta, Georgia. Awesome. That's a great town. I like that town. Really good cigar clubs in Atlanta. Okay, excellent. So here's the class agenda. We'll have a short explanation of the Tech Academy, like who is this organization delivering this free class, and then we'll get into our workshop, a day in the life of a software developer. We'll have a brief Q&A session, although particularly with this workshop, I like to get a lot of input from people in chat as we're going. I want to find out what your experience is, interests, that kind of thing. So be prepared to watch chat and participate if you want to. When we're done with the Q&A session, we'll have some information about our boot camps, like how do we help people. There's a free gift waiting for you at the end. It's actually really, really cool, so stick around. Whole class should take about an hour and a half tops. So brief word about our coding boot camps. First of all, what's a coding boot camp? Do me a favor, drop into chat, yes or no. Have you heard of coding boot camps? Give me a yes or no in chat. Some yes, some yes. Okay, good. So mostly yeses. Excellent. That'll be really brief. They're just intensive technology training programs that are designed to help people break into tech in entry-level positions. Depending upon where you go, they might last anywhere between 3 and 6 months. And they focus on modern practical skills, stuff that you need day one on the job. We've got 10 years of experience in this area. We've been offering thorough, budget-friendly, flexible, trusted coding boot camps since 2014. Our programs are cost-effective. They're self-paced, which is kind of unique in the bootcamp industry. They're self-paced, which gives you a lot of flexibility. And they're tailored for beginners, like really, truly, people that have no prior technical or coding knowledge. That's who the programs are designed for, which is pretty cool. And of course, they cover in-demand skills for the tech industry. We've got really great reviews online. Like I said, they're flexible to fit around your schedule. And most importantly, we're trying to prepare people in these boot camps to have what we consider a really well-rounded toolkit. We're not going to give you like one tool that's popular right now, but might not be a year from now. We give you a really well-rounded toolkit. Price-wise, the average cost in America for boot camps is around $13,000 or $14,000. Ours are well under the national average. In fact, we have boot camps that start at under $6,000, right? And I just want to read our mission statement because it kind of explains who and what we are, but also why we deliver these free classes. The mission statement of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. Our product is you working in tech. I just give some quick expectations about the class. I will be giving you a lot of simple definitions for technical terms, explaining technology-related concepts in plain English. This particular class doesn't have any coding. We do deliver free coding classes to kind of get your hands dirty, like writing code and learning some of the fundamentals. We'll give you some links later on. Actually, I think Cheska, can you find the link for our next coding class on Meetup and drop that into chat? In case anybody here wants to actually do some coding as well. While she's doing that, give me a yes or no. Have you ever done any coding? Yes or no? Drop that in chat. Couple yeses, some more yeses, a no. We've got a experienced here, like C# developer with 10 years of experience. That's awesome. That's Michael. Good job. That's great, man. Okay, good. So mostly yes, some a lot. All right. That's the wrong link, Cheska. That's the link to the full code for a blackjack game. Yeah, if you grab that link, you'll see a bunch of code in Python that you probably won't understand. That's what we use in that class for next week. I'll bet that's what that is. Oh, good. Someone says they've learned HTML and CSS. They're currently learning JavaScript. That's awesome. Starting with web development is great. Okay, I'll be Cheska will drop that in when she gets the chance. I'm going to go and move forward here because this is a lot of fun, and I want you to see all this. Let me get back in here. Okay, so let's talk about the day in the life of a software developer. Yay! Okay, so I'm going to cover here, like, what is it that keeps a developer busy? Of course, I've kind of messed up the animation on this. Give me just a second. Okay, good. So these are the principal kind of activities that will keep a developer busy throughout the days and weeks of his or her job. Now, the first thing I want to point out, and this is actually a really important thing, is that coding, like actually writing code, is only one of 7 different large fundamental areas that you'll work in the tech industry. And I bring that up because we still hear this after all these years of the industry being around. There's sometimes a conception that when you're writing, like when you're a coder, when you're an engineer, when you're a developer, whatever the term is, that you spend most of your time typing at a keyboard, writing code, probably in a dark basement, consuming caffeine and junk food. Well, it's your choice whether you want to consume caffeine or junk food. I, of course, have my coffee right here, so I've got the caffeine covered. But it's absolutely not true that you spend most of your time like just writing code. In fact, I had a good friend almost a decade ago who was considering, breaking into tech. And the reason he ultimately decided not to, and I could never convince him of this, he said, I type too slow and my hands get sore when I type a lot. And I almost laughed out loud, not to be rude, but coders don't type fast typically, or it's not part of what's needed at all. In fact, a lot of the time when you're writing code, it'll look like this. If my video is on the screen there, even if it's small, this is what it'll look like. And then you'll write a few words of code, and then you'll run it. And then you're thinking. And then you write a few more lines of code, and then you run it, and you're thinking. You're never typing fast, unless you happen to have that ability. It's not required. So we're going to break down each of these 7 things. And like I said, look at what is a day in the life of a software developer? But I just want to handle that one first, because I see this fairly often that people think you're going to spend all your time writing code. No, you're absolutely not. Probably about 30% on average. Tops is spent writing code. So what are all these other things? Well, let's break them down. Let's talk about coding. What kind of things will you be working on? And that's what you see, these 4 sort of categories of work here. When you say you're quote unquote writing code, what are you doing? Well, the thing that most people think of is creating some new feature. Like you're working on a word processor program, and you're going to add the ability to insert images into your document. The software couldn't do that before. It needs that feature, and you're going to build that feature as an example. And absolutely, this is what most people think of when they think of software. Answer a question in chat for me. Can you think of a piece of software that you use a lot, that you like? Whether it's a game, a productivity tool, Discord, whatever. Think of a piece of software you use a lot, and more than once you've been using it and you go, man, it would be really cool if this program could do X. Give me a yes or no. Yeah, Microsoft Word. I've had thoughts on that too. Yes or no? Have you ever had that thought while you're using software? Man, it would be so cool if it did this. Absolutely. And that's like new feature development. And it's really gratifying as a developer to work on those things, right? Let's flip it around though. Have you ever been using a piece of software and it doesn't do what it's supposed to, or it crashes? Of course, it's happened to all of us. So that's that second category, defect. You might be coding to fix a problem, right? You're going to remove an issue that'll stop a customer from being happy. This other one, though, is kind of interesting. Like, you as the user don't usually have any indication when you're using some sort of software system that work on risk has happened. But it certainly does happen, and usually it needs to happen more often. Isn't it like, have you all seen that, like, almost every week in the news, there's one technology company or another that's had some major security breach or ransomware or been hacked or leaked data or whatever? You all see this in the news, right? Well, part of the work you would do when it comes to actually writing code is write code to mitigate risk. You can never 100% eliminate all risk. The fact is that if a computer is connected to the internet, it can never be 100% secure, period. But there are lots of things you can do to help mitigate that risk. And often as a developer, you'll be building those things, which, while not visible to the end user, brings its own level of like satisfaction and gratification. Lots of people concentrate heavily on this area and become security specialists and are in high demand. And then there's debt. Now, this one might take a little more explanation. It has to do with that bottom sentence, upgrading the quality of already deployed code and infrastructure. Let me explain that word infrastructure. You can build a computer program, that's your code, but then that program has to live somewhere. It's got to be hosted out on the internet somewhere. It's got to live on some computer. It might need a bunch of things around it to help that program run. Databases and images and videos that it's going to use, all that kind of stuff. All that is infrastructure. In other words, infrastructure is everything besides your program. So if you have a bunch of already deployed code and infrastructure, in other words, you've got a program out there in the wild being used, there's a really good chance that parts of it are low quality. There's a lot of reasons why that would happen, but sometimes as engineers, as coders, we don't always get to deploy or ship the perfect code. Sometimes there's workarounds and hacks, just for a lot of very real, justified reasons. But I can tell you that each time you or your team does something like that, you've got this little thing in the back of your mind, you've got to come back to that later on. The coming back to that later, that's handling debt. They call it technical debt. So on the screen here, you see the 4 rough categories of type of coding you might do. Each of them has their own sort of fascination and pros and cons and like way of thinking through it. But this is an engineer writing code. But remember, that's only one of 7 different things an engineer might do in terms of broad types of work. Let's look at meetings. Meetings happen. Now, I want to watch chat for this. How many of you have ever been in a meeting and felt like that meme of this could have just been an email was appropriate? How many of you have you been in a meeting where you're like, why are we even doing this? Why are we all gathered together like this? Oh, a yes with an exclamation. Absolutely. And absolutely LOL. Okay, now, I knew it was almost a facetious question because we've all sort of experienced it. I will say this. I've been in technology for about 30 years. And a cool thing about this industry is that in general, there's not a lot of that in this industry. Again, every situation is unique, but in general, engineers and all of the types of people we work with to build and deploy and maintain these software systems, they're pretty pragmatic. They're like, listen, we just want to get the work done. And there's not a lot of the culture of meetings for meetings' sake that you might have seen in other places. Now, there's no guarantees of that. You might get a job at a place where they just love to have meetings, but it's not that common. I will say this. The 4 kinds of meetings that are listed here are valuable meetings. So I'm going to describe them really briefly. Obviously, design is important. I have a one of my favorite T-shirts says the following, and you got to listen really carefully. It says, weeks of coding can save you hours of planning. And of course, it's a joke. It should be the other way around. The truth is that, hours of planning can save you weeks of coding. And it's very true. If you don't spend that important time right at the beginning of designing a program or a feature or trying to make something, really thinking it through with your peers and talking through the design, even though you haven't written a line of code yet, you're actually doing, frankly, the most important work you will do as a developer. It's actually more important than the coding, because if you do that design work right, you'll spend less time to write the code. It'll be better. It'll fit the needs of the user better. It'll be more secure. It'll integrate with your existing computer programs better. All around, it's a better thing. So those meetings on design are actually really valuable meetings. Another kind of meeting you might have is just work planning. There's lots of different ways to approach like the business of making software. The whole area of project management in software is a fascinating one. But regardless of whatever approach your employer happens to take, those meetings are usually really good. It's really valuable to give thought into how much work are we going to commit to doing in the next week or 2 weeks? Like, what's an estimate of what it might take? Are there any particular resources we need to get that work done that we don't have present on our team? Are we going to need to seek some outside help? These are important things. And so you want to meet about those and coordinate. The other one, and this is actually, there's a special nuance here. You might be involved in client-facing meetings to gather requirements, to present your work and get feedback, that kind of thing. And I want to make a point here that if you're considering going into technology, if you will focus on learning not just the technical skills, but the soft skills like communication, collaboration, cooperation, you'll be doing yourself an incredible service. Again, decades in the industry, the people who really advance and make really good money and are respected and admired by their peers can communicate well. And especially if you can communicate with a client, you're really valuable. So you might have client-facing meetings. And then there's change management. Now, answer this in chat. This is, again, a facetious question, okay? Have you noticed how fast technology changes? Absolutely. Now, if you're building tools for your company with those technologies, even if you built them really, really, really well at one point in time, It's guaranteed that some amount of time later, maybe a few months, maybe a year, maybe 3 years, some part of those systems is absolutely going to have to change. But at that point, that system, that like computer program or whatever it is, has lived inside the ecosystem of your company for a while and is collaborating or communicating with a lot of other programs. And a change to that program is going to have ripple effects. It might be sending data to other programs. Are you going to screw up how you send that data by upgrading the program? It might need a whole new way of storing data, a whole different database. Well, is the database that's no longer needed being used by someone else? How do we make the data accessible to all the needed programs? This and many other considerations have to be thought of. And that's what change management meetings are all about is, okay, it's not just enough that the developer wrote the code and it's ready to be integrated into the program. Unless it's a trivial change, you've got to have at least some thought, some discussion around what's going to happen when we say yes and approve this change. And that's what change management is all about. And it's an important role, and it's fascinating to be at the table when those discussions happen. You learn so much, not just about writing code, but about software architecture and how complex systems interact with each other. It's fantastic. So those are meetings. And again, this is number 2 of 7 different kinds of things a developer might do in any given day. Any questions about meetings? Michael? Yeah, you're right. New version. Any questions about the meetings? All right. Are you enjoying this? Give me some love in chat if this is helping at all to clarify what developers do. All right, good. All right, so now another area might be reporting and admin. Okay, again, it's not development, but unless it's excessive in your company, this is still very valuable work for you to be doing as an engineer, right? There's some sort of report about productivity. Now, productivity for the technology industry is a hotly discussed issue. How do you actually track whether people are being effective and all that kind of thing? And I could do a whole seminar just on the different thought processes and attitudes and philosophies around how do you measure developer productivity. This isn't what I'm talking about there. I'm just saying no matter what system your company has for tracking what kind of work got done, you might have to spend a little time doing reports. Now, in some places that are very hands-off, this could be as simple as, did you fill out your timesheet for the week? There you go, done. Other places might want actually some report of all the different features or bugs or whatever that you worked on during the week and which ones are done and which ones are in progress. It just depends. But you might spend a little bit of your time with that kind of admin work. Obviously, there's communication back and forth, emails. Now, one cool thing about working in the technology industry is you operate in communication channels that very often are not email-based and are much more appropriate for the kind of work we do. As an example, there might be a program where you manage all of the tasks that need to be done by the developers. Each one is its own separate thing inside that program. And if there's some conversation that needs to happen about how to get that thing done or technical difficulties that were encountered while you were trying to do it, that conversation, that chat is done inside that program and it's attached to the work item. So you never have to hunt around in a bunch of different emails on what did Jane say about where I could figure out that database problem for what I'm working on? No, that would be a comment right on the task you're working on. And you could scroll up the history and go, oh, that's right. Jane said I need to do blah, blah, and blah. Okay, good. Now, that said, there's still email traffic. It happens in every company. So you're going to spend some of your day handling email traffic. You might spend some time updating your work records. And this one, for some people, is a lot of fun. For other people, they hate it. You might spend a little bit of time working on developer documentation. I want to paint a picture. You're a brand new developer and you're arriving at your very first job. You're already nervous as all get out. Even if you've gone through one of our boot camps, which do a really good job of handling imposter syndrome, you're going to feel some degree of stress and nervousness. And you're going to want to get your bearings. One of the more important things you can do when you arrive at that first job to kind of get your bearings is to get all the proper software you need installed on your machine, to get access to all the different places where the computer programs are hosted that you might be working on, to get access to all the different databases that you're going to need to work with. In other words, to just sort of like connect to all the things you're going to need. And it can be a really stabilizing experience. I've gone through it many times, and I've gone through experiences that are poor and experiences that are really, really awesome. The difference is how good the developer documentation is. If there's a really well-written, detailed, and up-to-date onboarding document, you can just be pointed to that by your manager and just start reading through it and take all the steps in it, get really nice descriptions of how your job works, what kind of applications we work on, how they're built, how to connect to them, all this stuff really written down well. And not only is that good for you, who else is that good for? It's really good for the existing developers who don't have to help you every 10 minutes as you've got yet another question. And then you feel nervous or like an idiot because you're asking yet another question. The point of all this is developer documentation can be extremely valuable to an organization. And so if you've got a great company you're working for, they might have you spend some of your time writing new developer documentation or updating existing documentation. Again, that's not coding. That's not software development, but it's really valuable work. Another category is working on infrastructure. Now, I kind of mentioned this before. Infrastructure is everything besides your computer program, but it's super important. If you go back 20 years, a computer program that was being used by a company, that program, more often than not, was installed right on an individual's computer, and only that person could use that program. And we'll move forward a little bit, and a company might decide to have one big computer in their offices where they put the programs that people need to use, and from your computer, you would connect into that, they call it a server, into that, main computer, and you would be able to use the computer program that you needed to access. That way you'd connect to it. And now, move forward, a lot of the times, those programs and things that you need to use in your company aren't even on computers that you own. They're on computers that are owned by the big cloud companies, like Google Cloud Platform from Google, or Amazon Web Services from Amazon, or Microsoft Azure from Microsoft. So notice that the only thing that was constant there is the program. What changes is, where does the program live? Where is the computer that the program is running on? How does that computer communicate with other computers and programs? All of that is infrastructure. And as a developer, you actually have to be concerned with this stuff. It's not enough just to know how to make the program. You got to know some things about how to install it somewhere, how to get it to be able to communicate with other systems. That's all infrastructure. And so these are some of the 4 different things that you might need to spend your time either working to maintain or building yourself. Where are you going to host your application? How do you set up the network so your application can communicate with other computer programs? You might need to maintain a specific computer, a machine, that we call a build machine. This is a computer whose sole purpose is to take the code that your developer team is writing, to take that code and turn it into a working program. That process is called doing a build. And you might have a specific machine that's the only purpose it's used for. And you might need to adjust that machine. And then there's things called code libraries. That's a bunch of pre-made computer code that you can make use of in your programs that you're creating. Well, you sometimes have to write those libraries, or you have to switch them out for new versions. Again, I want to point out, none of this is actually writing computer programs, but it's vital work for an engineer. All right. Another thing you might spend some of your day doing is helping your team. Having done this for a long time, I can tell you one of the things I truly love about this industry is it is a really collaborative industry. Like you work with a lot of different people, and they're cool people. They love to solve problems. They're really creative thinkers, right? And for the most part, they're absolutely not afraid to ask for help or to help others. It's really, really neat, actually. Give me a yes or no in chat. Have you ever worked at a place where you really didn't feel safe asking for help or asking questions? You ever worked at a place where you didn't feel safe asking for help or asking questions? Answer that in chat. Yeah, a couple yeses right off the bat. It happens. And look, I'm not going to say it never happens in technology. But if I look back over the last 10 or 20 years, I actually can't think of a single place that I've worked where it was that kind of environment. So again, there's no guarantees on this. You might pull the short straw and find a company that like is kind of rude. It's just so super rare, which is really, really cool. Okay. So let's talk about the kinds of help you might either receive or give to your team, right? Debugging. If there's a bug, some sort of like failure inside a computer program, one of the most valuable things that can happen is if someone else comes and looks at it. And I'll tell you what, a lot of the time, that's actually all it takes to solve what's going on. It's almost like magic, but it really isn't. Just getting a second set of eyes on something that you're like deep into, and you're like just beating your head against the wall and you can't figure out what's wrong. And as soon as some other developer comes and sits down and looks at it and they go, hey, what's that? And you look at the screen, you're like, oh, that. Yeah, I didn't notice that. Boom, fixed. And even if it doesn't happen that fast, which actually happens a lot, right? But even if it doesn't happen that fast, just that second set of eyes and a different way of thinking and approaching the problem is really, really, really invaluable when you're tracking down a really gnarly bug. So you might spend time helping your teammates with that. There's a whole nother sort of discipline or practice called pair programming. Actually, it's not that common, but when it happens, if you are the kind of person who can experience it, it's one of the most valuable experiences in all of technology. And here's how it works. 2 developers, 1 keyboard. I know that sounds really simple, but think about that. You're working on building a new feature or handling some technical debt or handling a bug or mitigating risk. Remember those 4 categories of coding work items? You're doing some of that work, but it's both of you. For a little while, one of you might drive. They might have the keyboard and be writing the actual code and running it to see if it works. And then you might switch out and the other person writes the code. But regardless, 2 people are literally working together as a team. Now, have you ever had to type in front of other people? Now in the age of Zoom, post-COVID, a lot of us have had the experience where we're in a Zoom call, and we're sharing our screen, and we have to type. And every time you make a mistake, doesn't it just punch you in the gut? I'm not immune to that. I'm a pretty tough guy, but it's embarrassing. Now, picture that, but it isn't just a typo, it's a programming error, and you wrote it the wrong way and it didn't work. I'm bringing all this up because this pair programming thing, you've got to humble yourself to go, I might look like a fool in front of my teammates. And you do it anyway. I could do a whole seminar about pair programming. It's amazing. Part of the reason it's amazing, besides the fact that you just get exposed to different viewpoints and you learn really cool things, is this. You're not going to get made fun of by your teammate. I've never seen it happen in pair programming, because the hidden secret, the hidden dirty little secret about the technology industry and about programmers specifically, is that every single one of us, no matter how long we've been in the industry, every single one of us feels like an imposter. I've written thousands of programs. I've worked at 30 or 40 different companies, from tiny mom and pop to like big Fortune 500 companies, right? I've seen a lot, and I am painfully aware of all of the things I don't know. I've experienced it so many times of 75 or 80% of the time, the first time I write something, it doesn't work. And that's after years of experience. All of us know, even though we don't maybe talk about it a lot, that there's so much we don't know. But what we do know is that there's no problem we can't solve eventually. And we know that the person right next to us is in the exact same boat as we are. So it's very easy to reach out to them and go, I'm just beating my head against the wall here. What am I missing? Help me out. It's a really cool aspect of technology that not enough people talk about, in my opinion. We all have imposter syndrome, but because everybody does, it's really easy to ask for help. And in the very rare instance that you find someone that's a jerk to you because you ask for help, you are in the wrong place to work. It's not the industry, it's them, it's that person. And again, it's just extremely rare. Michael, I understand, says, no, it all scares me at this point. I totally understand. I have a side project. Just as an aside here, I do a lot of side projects. I like experimenting with things, and I like getting paid, when I do them. So I signed a client up for a really cool sort of automation program I'm going to put together for them, right? And of the 3 types of work that this automation program needed to do, I know how to do 2 of them and have experience in doing those 2. The third one, I'm like, I know it's possible. I have to kind of figure it out. And so it took me about an hour to solve it. But during that hour, I'm like, oh, wow. Not quite sure how this works. Wow. Did I bite off more than I can chew? But at this point, I've been in that exact same position so many times, it doesn't bother me as much. But it still does. It still does. But like I said, I know there's no problem I can't solve. It might take me longer than I wanted it to. I might have to reach out for help, but there's no problem I can't solve. So it does still scare me, Michael, and for everybody else, it does. Like, it's a thing to acknowledge in technology. There's literally no way that any one person could know everything there is about everything in technology and how to solve every single problem right away. There's literally no way. But if you concentrate on learning the fundamentals, the principles behind computers and programming really, really, really well, you can solve anything. You can always fall back on the fundamentals. And by the way, that's part of why our boot camps do so well, is because we teach those fundamentals that underlie everything. So you can think like an engineer. You can think like a computer. And when you encounter a new problem, it may be new to you, but it's based on stable, known principles that you were taught, and so you can figure it out. All right. And then there's training, or talking through a problem, or doing what's called a code review. Somebody completed some work, but before they actually make it official and, integrate it into the computer program, they want you to review it, get a second set of eyes. So these are the kinds of things you might do in terms of helping your team. Any questions on these? All right. What's another category of work? Well, building the software. I want to be very crystal clear here. This does not mean writing the software program. That's called coding. That's actually like sitting down on the keyboard and typing in the instructions. That's coding or writing the software. building the software is different. And I kind of just threw off a casual explanation on this a few minutes ago, but I want to elaborate a little bit. When you are writing a computer program, you're typing a bunch of text into a code editor and you're creating text files. Now, when you see them on the screen, if you're using some, nice editing software, some of the words might be in different colors to bring focus to them, help it be easier to read through the code, that kind of thing, right? But at the end of the day, all you're making when you're writing a program is a bunch of text files. That's the first thing to clarify. So how do we go from a bunch of text files to an actual running computer program? Well, let's think about what's in those text files. The text is written to conform to how a specific programming language works, like JavaScript or Python or C# or any one of hundreds of other programming languages. When you typed in those instructions, you're writing them, hopefully, to be exactly how that language works. But then you take that file or a bunch of files, right? You take these code files, and again, they're just text files, but you feed those text files into a very specialized program called a compiler. And this program does something really awesome. It takes that text, those instructions that you wrote, and it turns them into instructions that the computer can actually perform. Now, without going way deep on this, we have other classes where we go deep into this. And on the bootcamp, you learn all about this in really good detail. So without being super nerdy about it, when I say that the compiler turns your text files into instructions the computer can actually execute, here's what that means. Your computer, I'm tapping on my tower right now. Your computer has inside it this thing called a central processing unit. People call it a CPU or a chip. And we've all heard that term, right? What's interesting about that CPU, which is just a bunch of electronics, is that it has built into it a set of about 20 or 30 instructions. Those are the only things that CPU can do. In other words, they're the only things the computer can do. There are things like take in some data from an external device like a keyboard or a mouse, or send out some data to an external device like a monitor or a printer or another computer. Or it might be things like do some math. It might be things like process some text data. But there's only a limited number of things that the CPU can actually do. They're literally physically built into that CPU. So when I say instructions that the computer can actually perform, I just mean a big list of instructions that are those instructions that your CPU is expecting. Now, they call that machine language is what they call it, okay? But all you really need to know is this. You have to have some process in place that'll take you from a bunch of text files that you wrote that contains all of your instructions. You have to have some process in place to go, okay, I'm done for right now. I would like you to turn this into an actual program and run it so I can see whether it does what I want it to do. That process is called making a build. And a build is composed of three broad things. This thing you see on the screen called the executable, it's a nice fancy word. All that is a file that has that machine language instructions in it. Those instructions that the CPU can actually perform. That's an executable. Does anybody know another word for that executable? Put in the chat if you think you know what another word for an executable is. Yes, Michael, it's called a binary. Now, we could do a whole different thing on binary. It's just a different number system where you can keep track of amounts and stuff with ones and zeros. That's all you have is ones and zeros. But those machine language instructions that are built into your CPU, they are specific unique patterns of ones and zeros. So we call them binary instructions. And so a file that contains a bunch of those instructions is called a binary or an executable. And you have them all over your computer. If you have a Windows machine and you use Microsoft Word, somewhere on your computer is a file called word.exe. The exe stands for executable. And what's inside that file is thousands of instructions, one after the other, that are written in machine language. You could read it if you want to, try to open it up, but it's just a bunch of ones and zeros, and it'll make you fall asleep. But your CPU understands it. That's called an executable. So, of course, you need to have that. That's your program. That's your actual program. That's the thing that when someone double clicks on it, it'll run, right? Another thing that you might need to have is what we call libraries. Sure, you wrote your program. You created that. But in order to make it easier and faster, you might at various points make use of other code that someone else wrote. A real common example is random numbers. I got to tell you, by the way, this may seem surprising, but it's really, really hard to make a computer generate a truly random number, because nothing random actually happens inside a computer. Computers are not capable of randomity. They're not capable of just doing something for the heck of it, or doing something and one time it produces this result, but then another time, for no reason, it produces a different result. Computers can't do that. So generating random numbers is really hard. So brighter minds than mine wrote code that does that. And since I don't want to have to try to do that, if I ever need a random number in my programs, I'll just find a library, a set of pre-made code that generates random numbers, and I'll pull that into my program and make use of it. Well, if you have built a program that's going to use that library, you have to include it in this build package thing. And the build package is just a folder with a bunch of files in it. And finally, there's things like assets. Remember, your program is just a bunch of executable instructions, but what if your program needs to display some images or play some videos or whatever? You need those images and those videos in the same location as your program. So I know this is a long explanation, but I just want to illustrate a lot of what you might spend time doing as a developer. You need to be able to create those build packages. In other words, all in one folder is everything that is needed if you chose to deploy your computer program somewhere and turn it on. That's what's in a build package. And there are specialized programs that help you do this. They're called build agents. It's just a special program that'll do all these processes and collect together in one folder your executable file, any code libraries that your program needs, any assets that you might need, configuration files, all of it's in one place. And then you can give that folder to someone else if you want, and they can install it on a computer and run your program. It's really cool. So you might spend some of your time in the given day in the life of a developer creating build packages. Actually, you'll do it a lot, right? You also might spend some of your time, let's switch over. You might spend some of your time running automated tests. Like you might design some tests that as soon as your computer program turns on, we'll run a bunch of tests against it to make sure that it's behaving properly. And more importantly, you want to run these tests to make sure that a change you just made to the program didn't cause a problem somewhere else that you didn't know about, which does happen. They call it a side effect. So you might spend some time running these tests. Also, you might have different places you need to install your program for different purposes. They call them environments. You might have a computer you install the program on just for the developers. Nobody else looks at it. It's just for you developers to see how things are going. You might have a whole different computer you want to install the program on for the testers in your organization, the quality assurance personnel. You can put a copy of your program there and they can test the heck out of it. They can try to break it, hack into it, see if it actually works the way it's supposed to. And then most importantly, you've got a whole computer or sets of computers where you put the actual program that the users are going to use. Because you're doing all this to satisfy users. So you might have a copy of the program out on a computer, i.e., they call it an environment, that the users can access. I say all this to say that, like it says on the screen there, you might spend some of your day moving your code through those environments. You might be done doing development and go, all right, this code is ready for testing, and you'll have to put a new copy of your program that contains your change out on the computer that the QA or quality assurance people are using. All right. Any questions about these three concepts? I went into a lot there about building software. Any questions? Okay. This one isn't a shock. You might spend your time debugging because, big surprise, there's no such thing as error-free software. Period. Never happened. Not going to happen. Any complex software that you put together is going to have bugs somewhere. Never seen it that something's perfect right out of the gate. So, what kind of tools are you going to use to do this work? Well, one of them is what's called a code debugger. Now, without getting, again, super deep and nerdy, what's cool about a debugger is a special program that can hook into your program while it's running. And you can make that debugger program stop your program at any spot you want. Any instruction you want, you can stop the execution or running of your program. You can stop it right there, and you can see exactly what's occurring inside your program at that exact instant in time. What's the next instruction that's about to be performed? What was the previous instruction that was performed? What was the result of that instruction? Was it what I expected? And you can step through one instruction at a time until you find the exact spot where something didn't go the way you thought it was supposed to, and go, oh, this is where the bug is manifesting itself. Why didn't it do what I thought it was going to do? Why didn't it behave in the expected way? And so the specialized tools called code debuggers to help you do this. Another thing you might spend your time using are logs. Often these are just text files. They're big text files. And when you build a program, you can make it so that anytime something significant happens inside the program, it'll dump a little like text row into this text file saying, at this exact moment in time, the following operation occurred. Here's some extra data to help you understand it later. And your program will do this maybe thousands of times in a minute in these big log files. Well, if something goes haywire and you can't figure out what's wrong, you might spend your time going through those log files, but it's the same thing. You look for, oh yeah, that's expected. That's expected. That entry is not expected. That log is wrong. It indicates something's wrong at that point in the program. And so you'll track down when your program started to go sideways. It's almost like forensics. It's detective work. And for some people, it's absolutely fascinating. I love doing it. You have to think like the computer, one step at a time. This worked right. That worked right. That didn't work right. Why? What's going on? Yeah, Michael, you're right. And this part doesn't get enough discussion, but it's really, really cool. If you observe a bug, you might need to write up exactly how to reproduce that bug for other people. Let's say you're not going to be the person fixing it. You want to give another developer who's going to work on it the exact information they need to get the program into the exact situation where the bug will manifest itself. And that's what those kind of documents are for. They're really, really valuable. So that's debugging. You're going to spend some time doing that. Again, that's not writing code, but it's really valuable, and it's something you can spend your time on as a developer. So, having gone over like the kind of activities you might do in any typical day, I just want to talk about what the successful attitude of a developer is, right? Let's say you get that first job, or you've been in the industry a while and you get the new job, or you get a new position at your company. One of the first things you want to do is just find out what exactly is needed and wanted from you in that role. You may have been hired under a specific type of role on the job requisition, but sometimes the kind of work that's needed right out of the gate might be a little different than what the job title suggests. You want to find out, what kind of work do you need me to be doing right away? What's expected in terms of like work patterns and communication with my fellow peers, and like find out what's needed and wanted. Don't assume. And then having found that out, just do it well and quickly. Now, I'm acknowledging that every one of us will probably struggle with that, like, imposter syndrome, or like, oh man, this is rough or whatever. But all of us are dealing with that. Just tenaciously apply yourself to the things you're supposed to do. Don't be afraid to ask for help when you need it. Don't be afraid to get up and walk away for a bit when you're like grinding on something. Give yourself a little bit of space, come back and attack it again, right? But just work diligently and hard and exceed expectations, and then repeat that. That's all there is really to it. No one expects you to be perfect right out of the gate with anything in technology. Yes, as you get more and more experience and move into more and more senior roles, there are certain things where they'll be like, oh yeah, that should be trivial and you should be able to handle that. But you'll be able to, because you'll have deep experience. But then when something's new or ambiguous, no one's going to expect you to just solve it instantly. We get paid well in technology because we solve problems that are hard to solve. And the solving them is very valuable to people in terms of productivity, making money, selling product, increased global reach, whatever the company's trying to do. With technology, we can make that possible. So they're not easy problems very often. No one's going to expect it to be an instant fix, but just keep diligently working at it. And like I said, ask for help and give yourself some space and walk away when you're going to bang your head against the wall. All right. So that's the day in the life. We're going to move on to the next stage of this, which is some Q&A, okay? I've asked a few questions along the way, but I really want to give everybody an opportunity to just like ask anything they want about being in technology. Even if it's beyond the scope of what I put in the slides, here I am. I've worked in tech for decades and I'm a big old nerd and know a lot of stuff. A lot of stuff I don't know. We've covered that, right? What questions do you have about tech or boot camps or coding or like the industry or getting hired or anything? And it's fine if there aren't any. I want to give you that opportunity. I'm a nerd in the wild and you can talk to me. Yes, I'm being silly. All right. So stick around for your free gift, especially based on what we just talked about. I think you're going to really like the free gift. Okay. So let me talk a little bit more about the boot camps and who we are and what we do. You look at all these symbols on the screen here. We have 12 online boot camps. And you can see these boot camps cover a wide range of technology subjects like artificial intelligence. You probably heard a little bit about AI recently, right? Computer programming, website development, cybersecurity. I mentioned that tonight because it's super important. Design, data science, video game development. I hear that industry is on the up and up, or is on the up and coming up. Mobile app development, all of it, right? In fact, we've got more certification programs than any other boot camp on earth. And this is the part that I'd really ask you to pay attention to, because if you're trying to break into tech, you've got a lot of options. I'm not saying that our boot camps are the whole best in the world. I do love them, but they have very specific characteristics that I'd like to tell you about, because maybe they're a fit for you, maybe they're not. For one thing, the boot camps are self-paced. You're not in lockstep, everybody going through the same material on the same day, one day after the other. They're self-paced, which means if you get slowed down on one spot, you've got the time to understand it and then go faster on other spots. It's a really wonderful way to learn. But of course, you've also always got access to instructor support. The boot camps are really flexible. The students set their own study schedule, which is pretty cool. And you can enroll any day of the year. We, of course, have really well-rounded content. It's very in-depth. As I said, we concentrate on the fundamentals, right? And they're affordable, priced under the national average. This part's key. Every one of those boot camps you see on the screen includes not just job placement training, like learning all about how to get hired in the technology industry, but they also include specialized job placement assistance from people who that's their sole job at the school is to help you get hired. But most importantly, all of these are designed for absolute beginners. No technology knowledge or coding experience is required, so you don't have to be a nerd to get through these things. We consistently land on every major best coding bootcamp list out there. Our average review rating across all the major bootcamp review websites is 4.8 out of 5 stars. And that's based on student and graduate feedback. People say really nice things about us, which is cool. So why work in tech? You've kind of learned a little bit about like what a day in the life of a developer might be. Now, bear in mind, developer isn't the only role in technology that we can prepare you for. But let's just look at tech in general. Why work in tech? Well, it's got really good work-life balance. You're not working 60, 80 hours a week. And remote work is very, very real, especially nowadays. It's also, as I kind of have tried to communicate tonight, it's a really creative industry, and you can take a lot of personal pride in your work. It's also a stable industry. Computers ain't going anywhere. And as long as you pay attention to what's needed where, and if you just continue to learn more, you'll always have a job. And the jobs pay well, and you get regular increases in pay. Now, that said, our approach to getting into tech is, of course, boot camps. You can do self-study, you can go to college, or you can do a boot camp. Those are the only 3 ways to get into tech, okay? What are the barriers, though, to doing a boot camp? The first one, and it's a big one, we got to look at it, is money. It costs thousands of dollars to do a boot camp, and with good reason. There's a lot to get through and a lot of infrastructure and support to help you get through this much training and experience in a short period of time. Now, that said, we've tried to solve that or make it easier to handle by providing multiple financing options at the school. At the Tech Academy, a lot of different ways to handle the money part of it, including a really significant upfront discount. If you just pay for your bootcamp up front, it's like 40 or 50% off. It's really, really good. Also, we've got monthly payment options if you don't have really good credit. And really, there's an option for anybody who wants to break into tech. But here's how I really feel about it. And yeah, I've got a biased point of view. I understand, okay? But I've just made it my mission to help people break into tech for a long time now. And having worked in this industry and seen what happens when people break into the industry, I really feel like completing a Tech Academy bootcamp is actually an investment in yourself, legitimately. The average wage of our graduates upon completing the program and getting a job is $60,000 a year. For their first job, that's the average. That's $30 an hour. And within a year, you can be making 70 or 80,000 a year. It's very real to break 6 figures within a few years. And experienced engineers make 140, 150, 180, 200. And they're not working 60 or 80 hours a week. And they've got good work-life balance, okay? So another barrier to doing a boot camp, frankly, is the time. There's a lot to get through in a short period of time. Now, some boot camps kind of try to solve that by running their students in what are called cohorts. They'll grab a big group of people together, and none of them start until they're ready for everybody to go. And everybody starts on the same day, and they go through the material all together at the same pace. And that way they're trying to, control that time aspect. Personally, I'll just be blunt. I really can't stand that approach. I know I personally have experienced it where, and we all experience this probably in middle school, high school, or whatever. We're going through the material, and some parts of it you're really understanding. You're getting it. You're going, yeah, this is awesome. And then one part of it, you're like, what? I didn't quite get that. And by the time you've straightened out your understanding, the class has moved on and you've missed stuff. And I'm speaking very personally now. It's heartbreaking for me when I see people who really gave it their all to try to break into technology, and that's what happened to them. I can't stand it. It's caused really, really bright, good people to feel like maybe they're not smart enough or tech is not for them, when truly all they needed was a little bit more help on certain aspects and not to have everybody move away from them in the curriculum. We don't do that. All of our programs are online. They're self-paced. You choose your own study schedule. Part-time study schedules are allowed, which means you can study concurrently to holding down a job and not worry about being left behind. Yeah, you've got to apply yourself diligently to it. There's a lot to get through. You're going to work hard, but you're not going to be at risk of the whole class moving on without you because you didn't quite understand one thing. The final barrier I want to talk about is the fact that you would need to have some technical interest or ability. Well, I'll tell you, the interest, you're all around this class tonight. You could have been doing, like I said, anything on a Friday night, and you chose to find out what's the day in the life of a software developer like. So probably there's some interest in tech, but it's the ability part. This kind of goes back to what I was talking about losing really good people who wanted to break into tech. You may have had the experience when you've been trying to study technology where you felt like the materials were beyond you or they were confusing, and you may have even felt like maybe you're not smart enough or there's something wrong with the way you think or whatever. I'm not saying that's happened for you, but I know it's happened for some people. The problem is not you. The challenge almost every time is that some educators assume too much prior knowledge on the part of the student. And they write their materials or create their videos or whatever training material it is, they create it assuming you already know some things. It's really hard to remember what it was like before you were an expert at something. We've had to work really hard on our curriculum to make sure we never assume too much prior knowledge, to really communicate and teach the actual fundamentals. But when you do that, it opens the door to tech for so many more people. In other words, you don't have to be a nerd to get through our programs. No technical background is needed to enroll. All right, now all that said, I've got a question for you, a couple questions. You don't need to answer these in chat. These are really just for you to think about. Are you working a dead-end job? I want to clarify what I mean by that. I don't mean it in a disparaging or rude way. When I think of a dead-end job, I think of a kind of a job where whether you're happy in the role right now or not, let's say you are, when you look forward a few years or a decade or spend the next 20 years doing this role, working in this industry, when you look forward in the future, is there an income ceiling? Like you look around and you don't see anybody making more than 100,000 in that role? Or if they do, they have to go get a master's degree and come back and then they only make 120? That kind of a thing. Or maybe, frankly, you're even unemployed. Or is it important to you to work from home or to have more time with your loved ones? Maybe you're working a job that you might enjoy it, but working from home would be great. But that kind of work you're doing can literally not be done from home. Whether your company would allow it or not, you can't do it. What if you're a bricklayer? What if you're a mason? What if you're a barista? You can't do that from home, right? So the big question is this, and it's a personal question: is it time for a career change? If it is, Tech Academy is the solution. We're career change experts. And I'm not just giving that to you as lip service. Early on, when we were designing the curriculum and dealing with our first few students, a very particular thing happened. Maybe our third or fourth student, it was a long time ago. He was a plumber. And he really wanted to break into technology for a long time. But he had done something really cool. He had managed to become a plumber and work himself up to the point where he was making about $60,000 a year as a plumber and was able to support his small family on that. But he looked ahead and went, man, I don't see any plumbers making $100,000 a year unless I own my own business and run a bunch of people. And I'm just not, I don't want to do that. But his big concern was, Erik, if I do this, if I make this jump, I can't afford a significant pay cut in my first role. If I drop too much below the 60,000 I'm already making, I'm screwed, man. I'm in big trouble because my life is already, I need that to support the way I am. And so that really influenced how we designed this and how we prep people. And in particular, it affected how we designed the job placement course and how we trained our job placement personnel. Because it was so important to us that people have a really good outcome. I bring that story up to just back this up. We are career change experts. We've been doing it for 10 years. This bridge, the orange bridge in the logo, is there to symbolize the fact that we are trying to be a route into technology. You cross that bridge into tech for everyone. We've been doing it for over a decade. I've already mentioned this, but most Tech Academy graduates make on average about $30,000 an hour in their first job. And it's not a small number of people. We have over 1,000 graduates who we've gotten into tech at everywhere from small businesses like mom and pops, medium-sized businesses, 30, 40, 50 employees, to the really big dogs. Every single big tech company you can probably think of, we've got people there. Nike, Facebook, Disney, Uber, Epic Games, all of them, okay? There's a reminder, we have open enrollment. You can start anytime. So I have something really cool for you. We decided to continue this in August. If this is something you want to do, or even think you want to do, this is what might be possible for you. If you enroll in August, first of all, it's a guaranteed 50% off on your tuition discount if you can pay up front. So a boot camp that might cost you 8 G's will cost you 4, as an example, okay? If something might cost you 16, it'll cost you 8. And if you're in America and you don't have a laptop to do the course on, if you want, we'll also send you a refurbished laptop so you can do your course on a nice, stable, good laptop. Also, for people that sign up in August, there's no sales tax. Don't get me wrong. We pay the sales tax for you, okay? But you don't have to pay it. And depending upon where you live, that can be 7, 8, 9, 10% of the sale. We'll also send you some books that are going to greatly help you in your studies. A lot of students buy these when they find out about them, but you're going to get them for free. We have several coding books and a technology dictionary with simple, clear definitions for thousands of technology terms. It can be super helpful when you're learning to code. So we'll ship those to you, okay? We'll also give you your own copy of our career planning guide. Now, this is normally something that we designed only for select graduates. It isn't out there in the public at all. It's not available on Amazon or anywhere else. This is a career planning guide that my co-founder and I wrote because we could find no effective guidance for once you land your first technology role, what do you do? How do you plan your career? What do you do during the first 6 months if you want to give yourself a solid foundation? What do you do during the first 18 months if you really want to get that raise really quick and make yourself like, really effective and a candidate for promotion? What do you do in those first 3 years? We laid out everything you should concentrate on and when. So you're not trying to do everything all at once. You've got a laid out sequence. That's the career planning guide, and it's super valuable. When I've personally done career coaching with people and helped them navigate those first couple, 3 years, by putting in place the stuff that's in this guide, I've seen people go from their 40 or 50 or 60,000 a year to 120 in those first 3 years. It can make a huge difference to have this information, and you get that for free. You also get 90 days of access to what's called the Tech Academy Accelerator. Now, this thing's a lot of fun. This is my baby, okay? For a long time, I wanted to have a platform where I could have an intimate, deep dive place for technology education. In other words, I didn't want to have to hold anything back. Not classes or presentations where they were designed for absolute new people, where I had to simplify everything, but classes where I could choose a subject, or the students could give me a subject and we could go way deep on it and just dump everything I know about that. And that's what the accelerator is. There's a lot more to it as well, but it's a subscription offering where you get weekly free workshops, weekly workshops with me with a super deep dive, no holds barred, open voice, open chat, communication all the way through. They're awesome. You also get access to over 100 free mini courses and 100 free educational videos. So there's a bunch to accelerate your career. That's why we called it that. And you get that for free for 3 months. And finally, this one's huge, unlimited job placement assistance. And we mean that. We're just doing this for people that enroll in August, okay? When you enroll and you get all the way through the program and you've done your job placement course and you're now working with the job placement specialists, no matter, as long as you're working on it, we're working on it. No matter how long it takes, we will be there with you, doing mock interviews, doing drilling with you, giving you additional things to study, helping with coding exercises, helping to prepare for an interview, whatever, all the way through until you get that first job. No one can guarantee you a job. It's just not a real thing. Okay. But we will do everything within our power for as long as it takes. And as long as you're leaning into it, you're going to get that job. So stick around for the free gift. It's coming in a second. If this is of interest to you at all, just go to this link and you'll find out more. Jessica, can you drop that in? Michael, I love that question. It's beyond the scope of what I teach tonight, but I'll tell you what, you really should join the accelerator. And like, we can dive deep into that. I won't even read it right now because it's a good question, but there's a lot in it. And that's a great question for the accelerator. By the way, you can subscribe to the accelerator for free for 7 days. So next Tuesday, when we have our weekly workshop, you could dive into that, and we can talk about that subject for a while. Okay, so Cheska dropped this link into chat. And if you have any slightest interest or thought that this might be a good thing for you, just click on the link and fill out the form. It's super simple. And right after you do that, you'll be given a series of steps all about the Tech Academy, videos and articles that explain everything about how we work and what the boot camps are and what courses are on them and what our philosophy is, and everything about it is explained so you can make an informed decision. Cheska, do me a favor. Can you drop in a link to the accelerator into chat? And if you can't find that, that's totally fine. I'll find it as well. I want Michael to be able to have that. Anybody else who wants to, okay? So I'm going to stop for a minute to take a sip of water because I've been talking a lot. And see if Cheska can find that link. And for anybody who wants to fill in this form and find out more. And then we're going to cover a free gift that I hope you're going to like. All right, while you're doing that, I'm going to pop in and see if I can find that link. All right, I'm almost there for you, Michael. Okay, let me go back here, pull up chat, pull up participants. Okay, so right now I'm dropping into chat. All right, use the second one. Cheska, I'll get you a different link. Okay, use that second link that says funnel.learningcodinganywhere.com. Okay, that'll take you to a form where you can watch a video about the accelerator and you can join. And like I said, it's the first 7 days is free. So you have an opportunity to check out all the resources and even attend next Tuesday's accelerator workshop, which I would love to have you there. There's so much fun. And if it's a fit for you, great. If not, just cancel. No charges. All right, let me go back here. By the way, we have a referral program, and it isn't just for our graduates and students. Referrals have been a big source of enrollments for us for years. We pay 5% commission checks for any enrollments that happen because of referral. So if you have friends that you think should, find out more about us, by all means, tell us. I'm going to give you an email in a moment where you can do that. I already mentioned the books, so I'm not going to go into a bunch of detail. We have 3 Learn Coding books. We have a coding book for kids and young adults. We have that Technology Basics Dictionary I talked about, the Project Management Handbook, which tells you all about like how software is made, and our book called You Are Not Stupid, which is one of the coolest books in technology, period. It removes all mystery from computers and technology. It's awesome. So the free gift is the actual Project Management Handbook. If you want to know how the software industry works and how like teams make software happen, this explains it in very simple, clear terms. It's super valuable. We'll ship a copy of this to your house. All you have to do, if I could have, there it is. Awesome. Thank you, Cheska. In chat, Cheska just dropped a link to an email address we use, books@learncodinganywhere.com. All you need to do is grab that and send us an email. Now in there, say, I'd like my free gift, please, right? But make sure you include your name and especially your mailing address. And once in a while, people forget to give us the address. And we have to email it back like, we'd like to send this to you, but we need your address, okay? And also, when you send that in, Tiana, I will get to that question. That's a great one, okay? When you send this in, if you have referrals, put their name and contact information in there. We keep track of that, and we will pay you a 5% commission check if they enroll, okay? Now, while I'm waiting for people who want to grab that email and send it in for their free gift, I'm going to answer a great question from Tiana. She says, do they hire newcomers in their 30s? Now, this is a really, really, really good question. One of the coolest things about technology, in my opinion, is that in general, we don't give a crap about how old you are. Now, there are little pockets, little certain companies, little startups with a bunch of, startup tech bro culture where they might care about those kind of things. Frankly, and this is just me, I'm going to be really rude, I would never want to work for that kind of environment. But I'm also not in Silicon Valley, and I've never been around those kind of companies. I've worked in Portland, Oregon, and all over America, but never near Silicon Valley where you find tech bro dudes. Sorry, I let my attitude show there. So the whole point about this is that in general, hiring managers and technology leaders don't care how old you are. There's 3 things they care about for hiring. And frankly, coding ability isn't the most important one, by the way. They do care about your technical chops and your coding ability. They care about how well you get along with others, because software development is a very collaborative teamwork activity. And this part's super important. They care how teachable you are. And more precisely, they're looking for people who are willing to be wrong. Willing to go, wow, that didn't quite work the way I thought it would. I better figure it out. Willing to go, man, I actually don't know that. And rather than be embarrassed about not knowing it, I'm excited because I get to learn a new thing. That's what they look for in hiring people. None of that is young, exciting, youthful, Gen Z, millennial, whatever. They don't care about your age. Now, I'm not guaranteeing 100% that that'll fully be your experience with every recruitment cycle you ever go through, okay? You might find jerks out there, but across the broad spectrum of technology, it's really, really rare for them to care about your age. And quite frankly, 30s is a nothing. When you start to be in your 60s trying to break into tech, which we've done with many students, now there might be a certain degree more legitimacy, but 30s is nothing, nothing at all. So yeah, it was a long-winded answer, but it was a great question, Tiana. Does that answer your question? Okay, excellent, thanks. So love the questions. Isha said, I'm thinking about going into data science. I'm not the strongest in math, but I am willing to put in the hard work. I'm struggling to decide which major to choose for this role. I'm good with people, but I also want a technical foundation. So that's a great question. Here's a couple comments on that. It's a great question. So here's the thing. If you hadn't said data science, but all you said was, I'm not the strongest in math, here's what I would have said. I am going to answer your question. Okay, I'm not trying to avoid it at all. But this is an opportunity to handle a real big myth about software programming. There's a real big conception still around the world that computer programming involves a lot of math. It absolutely doesn't. Period. End of story. The actual process of writing computer programs involves no math. Well, add, subtract, multiply, divide. But that's it. The actual process of writing these programs is not a math activity. The whole reason that came about was 40 or 50 years ago, when computer programming started to be a thing, colleges and universities did not have computer science departments. They didn't have IT areas. They didn't have computer engineering. There was no such thing. It was a new discipline. So universities had to figure out, where do we dump our classes in this new area of computer programming? And in almost every case, they got dumped into the math area. It's got nothing to do with math. They didn't know where else to put it. So there's been perception for decades that programming needs a lot of math. It's not true at all. Now, that said, because you do have a good question here, okay? From Isha. Remember that you're building a computer program to handle some real world situations. And sometimes those situations you're trying to handle do involve some more complex math. And yes, data science can be that kind of a problem. So the actual action of like writing the programs, that's not going to involve a lot of math, but there's going to be a certain spot in the code where you have to do some actual like statistical calculations, probability calculations, nerdy math stuff. Okay? There's no getting away from that in data science. So now I'm going to finally answer your question. I love that you're thinking about going into data science. And I'm absolutely not going to discourage you from it, even with what you said about like maybe not the strongest in math. Not going to discourage you at all. Okay? I will say this. One, very often, like better than 70 or 80% of the time, the first type of position you have in technology, or even the one you thought you were entering the technology industry for, ends up shifting and pivoting into another area. It happens all the time for a lot of different reasons, which we can go into detail, in another class. Okay. In other words, you may set out to go into data science and end up in another area, and super happy. You'll end up in that area through your own choice. Okay. It's not like, oh, you can't do data science, go over here. You may find that there's another area that you want to move into. But even if you do end up going into data science, you said something super, super important in that question. You said, I'm good with people, but I also want a technical foundation. Any single one of our boot camps lays in a phenomenal technical foundation that applies to any one of those 12 roles. And frankly, any technology role. Because I said it before, but I want to reinforce it now. Yes, you do need to learn certain hard actual skills. But the more important thing to learn is the principles underneath them. How exactly does computer logic work? What are the basic bedrock fundamental principles underneath all of this stuff? And it's important to learn that, because when you encounter some new problem that you haven't encountered before, that's what you're going to have to draw on. You have to go, okay, in a fundamental sense, what am I dealing with here? And I'll give you one example, and then we'll kind of end off. Have you ever stopped to think about what the purpose of a computer is? We use them for lots of different tasks. But why did humanity even make these machines in the first place? Here's the purpose of a computer: to take in data, to process that data in some way, and to send data on. That's actually the purpose of these physical machines. And ultimately, that's actually all they do. Now, they can take in all kinds of data, so it looks complex. They can do all sorts of processing of the data, so it looks complex. They can send the data on to all sorts of different places: people, other machines, other computers, displays, so that it seems complex. And it can be. But ultimately, any computer program that you're writing is only going to be concerned with doing those three things: taking in some data, processing it in some way, and sending it on. From that fundamental concept, which sounds super simple, I apologize, it's actually really valuable. But from that little teeny simple concept, you can start to build complexity. What happens if two computers are trying to work together to accomplish a task? How do we decide which of them takes in the data? Which of those two computers are going to do the processing of the data? When they're ready to send the data on, how do we coordinate that? Okay, yeah, that can start to get complex. but it's still based on that fundamental principle. So that's an illustration of why I just love what you said in your question. It's that technical foundation, and that's what we impart in our training. All right. I get super enthusiastic about that. I don't want to take up all your time. We've gone to an hour and a half, and y'all have been great. Okay. If you do have further questions, because I'm getting great questions here, send them in that email, books@learncodinganywhere.com, and we'll answer them. Okay. We also do have a link tree, by the way. I'm going to drop this into chat right now. Well, there it is. Excellent. You'll find all our links there, including links to future classes, our educational YouTube videos, books and dictionary links, all of it. Okay. And all of our social media. Please follow us on social media. But finally, if anything about what we went over tonight resonates with you and you're like, you know what, this might be for me, just fill out the form at this link. You never know. Like, if you've got a reach for technology, if something about this makes you go, I kind of like this, I'm fascinated with it, just fill it out and learn more. Find out everything you can about how we conduct our classes, what courses we teach, why we teach them in that order, how we prepare people for the job search, like all of it. Find out. And if we're the right fit for you, it'll change your life. It'll change your life. And if it's not, fine. No harm, no foul. Thank you all so much. I got to say, I do these every single week. Okay. Whether it's a coding class or a class like this, right? And I love them. I loved the questions tonight. You all have been fantastic. I really appreciate your engagement. I'm going to stop sharing right now and be able to say hi to you. Okay. Thank you all so much for attending. Please come to our future classes. And I'd love to see you all in the accelerator or in one of our boot camps. Thanks all.